So I've been meaning to visit the Old Bedford Level Canal for some time now, and I had some free time over the Christmas break, so on the 28th of December 2017 I thought I'd go down and spend a few hours there, which I did. I live about an hour and a half's drive away, and I was planning on going the day before, but the weather was really poor. But on the Thursday, the 28th, weather was it was a really clear day. It was cold. It was 2 degrees. It had frozen the night before, so it was a frosty drive and an icy drive down there. But it remained consistent at about 2 degrees throughout the whole time I was there. So as you can see, I've stood in the middle of the bridge at Welch's Dam, and I've zoomed as far as I can in with my Nikon P610. It's the baby brother of the P900. It has 60 times optical zoom with some added digital zoom. It's still pretty good though. You can see the bridge there at the top of the screen. That's the railway bridge, and that's approximately 3 miles away. And what you're seeing at the end there is Welney Bridge, which is exactly 6 miles away. The bridge itself is actually the white part that you can see, and you can see it's mirrored as well below in the water. But above there's kind of a structure there, and that had me baffled for a while as to what that was. It appears as though there's some mirroring going on, and the bridge is mirrored right above it there, really high up in the air, but it actually isn't. And when I go down to the other end later on in the video, to the other end of the canal, I'll actually identify what that structure is. But you'll see a car now come across, and that certainly is not mirrored in the bridge above. It's quite clear actually, there's no mirroring going on or any miraging going on at that sort of level. It's only when it's close to the water that this mirroring actually occurs. And I'm going to point out some other parts to this later, as to why Dave Murphy, when he went down the first time, didn't quite get the results he was after. So I took some measurements on the day. I measured the distance from the water up to my camera, and it was 13 feet from this bridge. And I took a few shots of where the water level usually is. It was about a foot lower than what it looks like it usually is. And looking at Dave Murphy's video as well, when he was there, it looks about a foot lower on the day I was there, which was strange because the fields surrounding the canal were absolutely flooded, which I'll show later on. So next I'm going to walk down to here, which is about 6 foot from the water to the camera. And the reason for doing so was because from up on the bridge I happened to notice that the right hand side of the canal, the riverbank on the right hand side, was encroaching into the river, into the canal. And what it does is it cuts off half of the bridge, half of Welney Bridge. You can only actually make out the left hand side because of the land, the riverbank in the way on the right. So it occurred to me that the kayaker on Dave Murphy's video was seen to go out of view at about, I think it was about 5.5 miles. And what could explain that is he simply went behind this section of bank here. And I'll show you on Google Earth shortly that the river actually does indeed encroach. The bank does encroach on that side. So it may be that he would have been seen all the way to the end, had he have sort of hugged the left hand side of the river. So as I start to zoom out, you'll see how clear the river is. So it's clearly best this time of year to be doing this sort of experiment. Dave's video back in 2016, I think he did it in the summer, and it was very overgrown and it was difficult to get a clear line of sight all the way through. Okay, so in Google Earth I've drawn a line from the centre of the bridge where I stood the first time to Welney Bridge at the other end, which is 6 miles. So let's just go to Welney Bridge. And I've gone to roughly where I think we can see to the bridge from Welch's Dam. I think this small section here is all you can see from Welch's Dam. I think if the kayaker was in this side of the river at all, then on the right hand side of this line, he would be hidden from view. And I'll show that later when I'm stood about here looking at the bridge to see what it actually looks like. But back to the point I was trying to make. If we follow this line back to, where was it? Here, you'll see how close the riverbank actually is to this line of sight. So I think there is still a window at this bridge, a very small window, but I think we can make use of it for experiments and tests, which I'll touch upon later. But now let's go and have a look at the video from about here. It could be a little bit further back actually, it could be here. Okay, so pay attention to the tree on your right hand side there, and I'll come back to it in a bit. But I'm going to pan around now and view Welney Bridge, and I'm going to zoom in and note also the 2 trees there. So the white part of the bridge that you can see is in the circle there, and it's also in the circle there. And I'm going to switch back and forth a few times between the 2 images so you can see what I think it is that you can see. It's obviously not in exactly the same place. I couldn't, obviously it's 6 miles away, and I'm dead central over the river on the other view. But you can see the white part of the bridge there, which is the white bit we were seeing back at Welch's Dam. And I'm now stood on Welney Bridge, looking back. So as I zoom in, you can see the railway bridge there, and as I zoom in even further, you can see the bridge over Welch's Dam, and you can also see the part of the riverbank that juts out there, sort of centre screen, the left hand riverbank. Obviously the sun's to the upper left, so it doesn't make for good viewing. It's a far nicer picture shooting from the other direction. You can see the trees there, one on the right and the 2 in the foreground. And they do cause some obscuration of the bridge as well. Okay, so when I turn around and cross over the bridge to the other side, over here is where the structure is that we could see above the bridge earlier if I just pause it. I then wanted to go and see if I could access the railway bridge by foot, and the closest I could get to it was here. This was just off the side of a road, and as you can see from what I was saying earlier, the fields are completely flooded. This, what you're looking at here, is the New Bedford Level Canal. So this is a different bridge going over the New Bedford Level Canal, but the one over in the distance is the Old Bedford Level Bridge. right over there. And that is looking back towards Welch's Dam. You can see just how much flooding is going on. Okay, so I was stood right about, where was I? Here. I parked up on this bend, on this bit of grass, and I walked up the hill and stood just about here. And that's about as close as I could get to it by road. So I was looking this way to start with at the workers just here, and this is the new Bedford Level Canal and the bridge over it that I pointed out, and up here is the old Bedford Level train bridge just here. So obviously all these fields, this field here, all this bit, this sort of band of fields here, were completely flooded as far as the eye could see, both directions. So there was no way I was getting across by foot. So the only other option left to actually access this bridge is either by boat or we walk down the side of the canal. But I do think it's worth doing at some point, because I'd like to get a measurement from the bottom of that bridge to the canal itself, so that it can be used in visual experiments with this bridge as a reference point. So I think it'd be useful at some point to get that measurement. So finally I took a walk over to the railway bridge to see if there's actually any way I could get across, but it was looking far too dangerous, so I thought better of it. So now I've been down there and established the terrain, I'd like to go back down primarily to establish how much of Walney Bridge we can actually see from this direction, by having a second person stand on the bridge and just do some tests. But I mainly want to start focusing on long-range Wi-Fi. So I'm going to play a video now, and this guy will go through the setup, and this is the equipment I intend to use.
Okay, so my original plan for these, yes, these right here, this is some cool stuff that we got going on right here, was to share the gigabit internet connection we have here at the office with my house, which is about 20 kilometers or about 13 miles away. Unfortunately, topography is a I would need a 60-meter antenna tower here at the office in order to achieve that. So we are going back to square one with this video, and we are going to structure this as holy shit, episode 4. Yes, we are already on episode 4 of this segment, and we're calling this one Long Distance Wi-Fi. So this is the PowerBeam AC, a device that I assumed would be a lot more expensive than it was. I mean, Ubiquiti sent it to us, so I had to look up how much it costs. It's only about $150, and with the kit, you actually get a variety of things. You get this weather-resistant plastic shell cover. You get this metal dish. You get this pole mount right here. You get this fastening rear housing doodad. You get this thing, which is like a mount for the other mount to mount the other thing with degrees on it. And then right here, you get the antenna feed. This is where the action happens. You also get a power over Ethernet adapter, an injector thing as well, because it is powered using PoE. So on the side of this guy, you've got your power as well as your link indicator, and then 4 bars to indicate the speed of the link. And that's pretty much it. Oh wait, except you get 2 of them, because the point of the PowerBeam AC is to be able to handle a 450 megabit link at up to 25 kilometers. Now we are not going to be able to mount these puppies up high enough in order to test that maximum range, but what we can do is we can at least do a limited test here in the parking lot and find out if the objective was to share a network connection with someone quite far away, whether it's a shed or whether it's a neighbor or whether it's from your office to your house if you happen to live somewhere flatter. Whether this technology looks pretty promising. Okay, so the assembly process is pretty straightforward. You take your antenna feed and you, no, wait, oh shoot, I forgot. Okay, right, you start with this bracket. You take this bad boy and pop it onto here. It only goes in one way. Then, yeah, you pop this into here until it clicks. There we go. Then you take your pole mount, stick it through the thing, and finally, optionally, you can put on the weatherproofing mount, something that I would definitely recommend. Please note, and this was pointed out to me by my editor the last time around when we did this before our SD card died, that this arrow corresponds to, I was sure there was an arrow. This arrow right here if you wanted to go on relatively easily. Now normally you'd have some kind of a pole mount here. So you'd go ahead, you'd put that on the pole and then you'd tighten it in and it would grip like that. But because we don't have a pole, at least not that kind of pole, if you know what I mean, we're just gonna go ahead and clamp it to a C-stand for our initial testing. Okay, so the PoE adapter here is optional if you have a power over Ethernet switch, but not everyone has one of those, so we're gonna show it using the adapter. Yes, we have power. Then, from there, without dropping it, you plug into the network port of a computer. So we're configuring our Internet Protocol version 4 settings, 192.168.1. anything other than 20 or over 254 or whatever it is. So I'm gonna go with 10. Subnet mask we can leave as default when you click it on there, and we're gonna set our default gateway to 192.168.1.20 and click OK. And check it out, we're logged into AirOS 7. So the first thing it tells you to do is change your password. I wish that more companies did this, where they actually force you to change your password before you can do pretty much anything else, but they don't, and such is life. So now what we need to do is we have to configure it with a static IP address that is on the same subnet as the rest of our network. So let's make it that. And configuration mode is simple. We actually have to change almost none of the settings on this bad boy to get it up and running, which is very, very cool. Okay, so now that we've reconfigured our network settings, we can go ahead and plug into an Ethernet cable that is on the rest of the network that we want to share. And then I'm switching back to my Wi-Fi here because I'm going to use this direct attach cable to set up the other dish in a minute. But now we should be able to navigate to it at the new address that I've set for it. Wicked. Okay, so now that this is set up, we're going to go to wireless and we are going to set up the mode. So this is going to be station point to point. So it was actually already correct. The SSID, we can make whatever we want. This is kind of like just a normal wireless hotspot for all intents and purposes here. Then I am going to turn our output power way down because we are testing at very close range here, and I'm going to leave pretty much everything else on auto except security. So I'm just going to put a rudimentary password on here, which is better than nothing, and I'm going to save my changes. So as soon as this dish, here we go, detects long-range SSID with the correct password, it should connect to it and we should have a link. But first, we need to hook up the other dish, or configure it rather. Ow! Oh, damn, that hurt. It is highly recommended to configure these while you are still very close to them, not after you have deployed them 25 kilometers apart. Okay, so we're logged into our second unit. Now what we're going to do is set up our network settings differently from the last one. So instead of .64, we're gonna go .66. So we have to go ahead and put this one then onto the main network here. We are very close actually. Okay, so we are on our last step now. We go to wireless on the second unit. This one is access point peer-to-peer. So the SSID we used was long range. Okay, we're leaving everything on auto, turning the output power way down. Okay, so the further the distance, the more important perfect alignment is, but at this kind of distance, it really doesn't matter much. So I'm gonna plug in my PoE injected powered thing. So this guy gets power. And then what you should see on that side, if you go around the side of the dish, is in a moment here, the link indicator should light up. Hey, there we go. All right, rock on. So now we've got a link. Let's test it out. Okay, so now what we do is we go back and change those custom network settings. We go back to automatic everything, blippity bloppity done. I'm plugged from the laptop into my PoE injector, into the dish, which is connected to the dish, which is connected to the server room, which is not disorienting at all. From there, we should be able to get an internet connection. Boom! Yeah, baby. All right. Okay, now speed test isn't always a solid indicator for us around here. I don't know what it is exactly, but the good news is that we're seeing very consistent results here. At least we were. And while not 450 megabit per second, and wow, the upload is going much better than the downlink. That's very interesting. We are still seeing speeds that are pretty darn reasonable looking for our dish Wi-Fi. What else we got in here? Oh, they have other tests too. So they have their own internal speed test. So you can go ahead and go, oh yeah, I want to use this one. Here's my username and password, and start. And this will tell you the just raw receive and transmit speeds between the two units. And we have a solution. This right here is a portable battery bank. Doesn't look exceptional. There's where it charges. Boom! AC outlet. So we're gonna use that to power the dish at the other end of the parking lot. Now, there is one more tool we're gonna need that I didn't show you guys before. This is really cool. This is the Align Antenna tool. So you can see right here what the signal levels are in real time. So watch, as I move the dishes so they point more towards each other, and the theoretically signal strength improves. Okay. Whew. Whew. Don't worry, I got this. Okay. So I'm just gonna start hiking. Okay. So with poor alignment at the lowest possible strength, we are still seeing about 200 megabit per second up and down. And that's with Ed standing right in the way of the antenna. Way to go, Ed. Actually, it didn't go down much. So inside the building, you had to make pretty big changes to the dish alignment in order to really affect this. Here, I am barely even touching it. So here we are, way down the road, still enjoying. That was pretty much the same speed test we were doing on the downlink. And however confusing this might be, it actually seems to be running a little bit faster on the uplink. So there you go. You can interpret that however you want. I'm sure with some tuning, we could actually get better speeds out of it, particularly down. There's probably something where I don't really know what I'm doing, but in spite of Ubiquiti offering to have one of their engineers help me, I was like, I want to see if I can do it. Let's see what kind of a result someone can get just following the most basic rudimentary guide, and there you have it. Holy long distance, 5 gigahertz, like beam access point to point thing going on here. Very freaking cool.
Okay, so I hope you got the gist of all that. My idea would be to utilise the pole that you can see here to fix the one of the antennas to, and I would fix it approximately 3 feet off the water. And this seems to be the ideal location as well. As soon as I was stood here and I could see the bridge, I think this would be a perfect position. So I've drawn an Autocad drawing here of what I intend to do. So this is looking at a similar view to what we've just looked at. There's the bank coming down, there's the pole, the green bit, and I've shown the dish attached at 3 feet. So the blue line there is the line, well, let's just follow it if I zoom right out. And incidentally, I'll just show you that's the ball, that's the 3,959 mile ball, and you can see the stretch of 6 miles here. So that would meet the receiver at the other end at 3 feet off the water as well. But of course that goes straight through the earth. Let's go to the middle somewhere. You see the blue line is now below the white line, which is the surface of the water, and that travels through 4 miles of water, so it's angled down very, very, very slightly, and it goes for about a mile before it hits the surface of the water. Then it travels for 4 miles underwater, and then it emerges about a mile off the target. So obviously, because this is line of sight, that would not work. We should not get a signal. If we do, then it's pretty telling. But if we don't, then what we should be able to do is to spin that, and this green line here is representing a pole that we can either suspend off the bridge and probably attach it to it temporarily, some sort of clamp, and we could put a pole downwards from the bridge. Incidentally, the top of this bridge is 16 feet to this handrail where my camera was. So we suspend a pole downwards to 3 feet off the water level, and if that doesn't work, we should theoretically, if the earth is a ball, we should be able to spin that pole round, put it up in the air, and we should start to see a better reception, or we should start to get a reception, and it should get better and better until 27 feet, where it should be perfectly aligned. So this red line here is looking out. We follow it all the way back. You can't actually see it here because it's on top of the, there you go. So the red one is going out exactly perpendicular to the dish at Welch's Dam. So just one final point while we're on this subject. There is the possibility that if this dish was angled down very, very slightly, and the one at the other end was angled down very, very slightly, that after 10 feet you would get a signal. But that would mean that in the center of the hump between the two bridges, the actual signal path would be literally touching the water right at the center. So I would say that it's an absolute minimum of 10 feet before you should start receiving a signal, and perhaps 10.5 feet would be realistic. Okay, so that's my idea in a nutshell, folks. I do intend to go down there again to do these experiments, but of course I'm going to need more people to help me, at least one other, but preferably lots of people. Ideally, not necessary, but if somebody has a Nikon P900 they could bring with them, that would be ideal. Also, I'd like somebody with computer networking experience to try and set the dishes up. The guy in the video did say it was fairly self-explanatory, but you know, it's always handy to have somebody who's savvy in these things. I already have a kayak that I can take with me. I've not bought the dishes yet though. I've been in touch with a reseller in the UK who has quite a lot of knowledge in these sorts of things, and you can get various different dBi gain sizes. There's 4 different sizes, so I was thinking I might, depending on cost, future-proof myself and go for the biggest one so that we can test it over greater distances. We need to sort out power supplies, like the battery bank the guy in the video had. We need some sort of power supply at both ends. I don't think it's necessary to actually transmit an internet signal between the two devices. You can use the software to sort of analyze the raw data between the two dishes. So as long as we can just analyze that data and look at the signal strength in real time, then that should suffice. So I've got no particular date set to go down there. I I'm hoping though to go in the first quarter of 2018 if possible, if there's enough interest generated and I get enough people to help. We've got to get the pole sorted out for the dishes to be fixed to, so there's a lot to do, and I don't think we'll get it done in one day, so it might be a couple of days. But of course we're not restricted either to Bedford Level for this experiment. I mean, it's nice to do it here because, you know, it's a standing bit of water that's got no waves or anything on it, but this could be done anywhere. I mean, we've got a range of 25 kilometers, so, you know, I'd encourage people to, you know, do this experiment in other places as well. 25 kilometers is like 2.5 times further than what I'm trying to test, so you don't have to be so low down to the water as I'm planning at 3 feet. You could be slightly higher, which means you could potentially park your car next to some water, maybe the sea, and go across a sort of cove. And you could fix your dishes to your tow bar of your car. So I think this experiment is a pretty good one, to be honest, and I'd love to see people leave comments and give me some ideas, you know, good, bad or indifferent, whether you like the idea, especially if you'd like to participate. I'll leave my email address in the description, so if anybody wants to contact me, that would be the best way. Thanks for watching, folks.